Hello everyone, today we are solving second question of the biweekly contest and the question is find a safe walk through a grid. In this question we are given a binary matrix and integer health. So we have to maintain our health positive. So health should always be positive and moving to a cell from another cell. Okay, so if we move to a cell that has cell value 1, so my health will reduce by 1. Okay, so I have to start from the top left and I have to reach bottom right, maintaining my health 0 in the path that I am following. So if I have that such path, I have to return true, otherwise I have to return false. So let's quickly see the examples. So in this example, if you see my health is 1, if I move to any cell that has value 1, uh, I can't reach bottom right with my health positive. So I have to choose a path where all the cells have value 0. So as in the highlighted portion, you can see this is my optimal path. Okay. If we move to second example, here my health is 3. And if you try to spend some time and see that if you can find any path, so you will observe that there is no path starting from top left to bottom right, maintaining your health greater than 0, you will be able to reach there. Okay. For the third example, my health value is 5, and if you see the highlighted portion, you can see that eventually when we reach from top to bottom right, I will have my health value as 1. So that is what we wanted. It should be greater than 0. So it's 1 to anything greater than 0. So I'll return true. Okay. So from the, the question, we see that it is a traversal tech. We have to follow grid traversal. Okay. Maintaining our health should be maximum when we move to a cell. Okay, so what I thought that I will be using BFS and I'll try to check that my whenever I move to a particular cell, my health value is at maximum. It is maximized. Okay, so I'll quickly walk through over the code so you will have a better understanding. I have denoted n as number of rows, m as number of columns. Though there might be confusion that here in the question they have denoted just the opposite, but this seems convenient to me, that is why I am using them. I initialize my d. So d is basically a 2D vector that is storing the distance, uh, that whatever the current health status, so that is being stored in the d. Okay, I'll maintain a q. So what q will do is that it will simply store my current xy coordinates and the distance that I have. Okay, so moving forward, I'll store as my distance at 0 comma 0. So what it will be, it will be simply the grid value that is present, that will be subtracted from the health. So if I am here at 0 comma 0, my health is 1 and the value here is 0, so health will be 1. Simply in this question also it will be 3 minus 0, and in this question it will be 5 minus 1. So similarly for initialization I have done that. So I'll, I have to minimize the reduction in the health. Okay, I'll put that thing in my queue, and until my queue dot size is greater than 0, I'll iterate over. Okay, here I'm capturing the my x coordinate, y coordinate, and the distance. I'll pop that element from the queue. Now I have added this condition that if my x coordinate and y coordinate, if they denotes that I'm at the bottom right cell, and in any case my distance is greater than 0, so that is what I wanted, so I'll simply return 0. Otherwise I will move into 4 directions. Another doubt we would be having that, hey, that if currently I am at this 0, okay, so now I can move top, I can move right, I can move down, I can move left. How will I decide that this can be a continuous loop? We could be we could be uh, we could be stuck in an infinite loop, so that we don't want. So we will be maintaining a condition that we will move to a cell, we will update a cell only and only if we find that moving from that cell to another cell maximizes my health to the cell which we are going. So let's understand this. It says okay is my function. It basically checks that my current x and y coordinates in which currently I am it is well within the boundaries or not. So I and j should be greater than equal to 0, I should be less than n, j should be greater than equal to 0, or j should be less than n. So it is a quick check that it is well within the boundaries. Now what it is doing, distance, which is the distance, let's see, here we are, okay, we are at 0 comma 0. Now with respect to question, I am moving x plus 1, x plus 1 is moving downward direction, so we are going down. I'll quickly check that if moving down is feasible or not. So how is that feasible? If the distance whatever I have here is, and if I reduce the cell to which I am going, if it is greater than equal to the current value which the cell which I am going to, that holds. So if that value is greater, then only I'll move to that direction. So as we observe that we are following this path, and moving back to this direction won't help me because my health will be same in both the cases. So that is why we will avoid those continuous loop. Okay, so if that is the case, that if I find my health value is being updated, that it is we have an option that moving to this particular cell from the cell that we currently are is feasible and it maximizes the health, we'll make use of that and we'll update in the distance value and we'll push back to the queue, so that we can again iterate over to the adjacent cells for the value updates. I did the same if we are moving down, I did the same if we are moving up, doing the same if we are moving right, and doing same if we are moving left. We can reduce this if cases by maintaining two for loops that have the directions 0, 1, -1 and 1, and this will reduce all this to just simply one case, and for loop will take care of that. But for better understanding, I followed this. And finally, if I do not find any path, eventually my q dot size will become 0, I will come out of the loop. And if I don't have the path, simply I'll return the false. As you can see example 2, if I follow any path, I will never hit this condition that I reach bottom right with the distance greater than 0. So I'll simply, my while loop will get over and I'll simply return false. So yeah, this was it for this question. For this question, the prerequisite or BFS, if you have the traversal knowledge in the graphs, it would have been much easy to understand. If not, do comment it out. I'll make a separate video explaining the traversal techniques. And do like and subscribe for more daily content. Thank you.